Hi, welcome back. First of all, I'm sorry for making the second video of the series so late. Let's come back to the topic. In this video, we are going to learn how to suspend a task execution for certain time in FreeRTOS. And again, the code is going to be Arduino oriented, and here is my code. So, I'm going to add the link of this Git repository where the code is present, and you can follow it and you can copy it. In this video, I'm going to go through it, and I'm also going to run the code on the board. Okay, so first thing first. So first we need to define or create the task handlers. So task handlers are going to be used for suspending or releasing the task from suspension. Okay, so I'm going to create two tasks in this code, and the first task is going to print hi, I'm learning FreeRTOS. The second task is going, and then it's going to there's going to be a delay of 1 second, and again the delay is not the Arduino's delay. This delay is the FreeRTOS function, right? And there's a delay of 1 second. The second one is going to print that I'm going to suspend the task 1 for 5 seconds, and then it's going to suspend it, and then there is going to be a delay of 5 seconds. Then it's going to release the task, and again there's going to be a delay of 5 seconds. So in this 5-second suspension, you will see this string should be printing 5 times because it's going to be scheduled 5 times while this is going to be in the suspension mode. So let's start from the beginning. First, we create two handlers. The syntax to do that in case of Arduino's is task handler underscore t. You will see that is this underscore t is in almost majority of the functions in Arduino's related FreeRTOS. Whenever you will find this, I will also going to mention the original syntax of FreeRTOS, so that if you are learning this course and on Arduino, still you would be able to apply the concepts learned here to some actual task. So some other board. Okay, so we do that. We write two functions. Those two functions will be scheduled as tasks. So in the first function, what I'm doing is, in every function I'm setting the serial monitor baud rate. You may do that in setup as well, because in both of the cases we will be doing serial communication in some certain baud rate, but the reason of declaring it here is that you may change the baud rate in some particular task. So in practical applications, you may need to communicate with different peripherals, and different peripherals are communicating at different baud rates. So in order to demonstrate that, I'm doing it here. Then you know that every task should never be returning. For that I put a while loop, and in that I put my own task, my own work. That is, first it's printing the string, and then it's going for a delay of 1 second. In the second one, what I'm doing is, first of all, I'm printing a string, then I'm calling a function vtask suspend. The same syntax is going to be in the case of other FreeRTOS cases. Okay, the original one. You pass the task handler of this task here. Okay, so I have linked task handle 1 with this one, therefore it's also printing task 1, although its name should be its name is task 2. It should be task 1 and it should be task 2, but it's just a naming convention that nothing, it's not going to affect the performance. Then after calling the suspend, putting the task into suspension, I'm putting a delay of 5 seconds so that it stays in that mode, suspension mode, for 5 seconds. Okay, so in this case, if it's going to be scheduled on the processor, it's going to stay in the suspension mode. Okay, when the 5-second clock will be completed, I will print that I'm releasing it for 5 seconds, and then I'm calling the function resume. So it will resume the execution of this task's functionality, and then I'm putting a delay of 5 seconds. Okay, as mentioned in the first video, that in case of Arduino's, the setup function is called first, right? It's executed first. So we have to write the FreeRTOS based code as well in this functionality. And you know, basically in the case of normal FreeRTOS scenario, we need to call the scheduler. That is not required here. So what we do is we create two tasks by calling xtask create. We give the function names here, okay, and then we give some some string, which is a name for humans to understand, some stack size to that function or that task. Then I'm not passing any parameter here. The priority is set to 2, and then one task handle is linked with this one. The same is the case with the second one. This blink analog is basically coming from the previous code, which I modified to make this one. So you can write anything here. You can write Ali here, you can write Hamza here. Doesn't matter. To satisfy the Arduino functionality, we need to have a loop function to compile this code, and we will leave it empty because the execution of the code will never come here. It will always stay here because the scheduler will be called, and the tasks should never be returning. Okay, so let's come back to the Arduinos. I copied the code here. The first thing is to set the board, which I set to Mega, okay, because the board which I'm using for demo purposes is Arduino Mega. Then I'm setting the processor. I'm having the new version that is having a new chip 2560 and the USB port. In case of Windows, it's going to be something like COM port 1, COM port 2, etc. I'm using Linux. So I upload it here to the board. And now let's set the baud rate, which is already set to 9600. If I restart the code, now you can see the strings are printing here. Okay. Now you can see the functionality here. This thing is scheduled 6 times while this was in suspension. And that is very much it for this video. Give me a thumbs up if you like it, and suggest me some topics of FreeRTOS which you want to be in the next coming videos.